types of atoms composing a single molecule of the substance. Therefore, the formula mass may be correctly referred to as molecular mass. So, how we calculate the molecular mass over here? So we count the number of atoms of each atom that is in the molecule. So then you multiply those by the average atomic mass unit and add all together. So in this case, the molecular mass of aspirin is 180.15 atomic mass units. Anionic compounds don't exist as molecules. So the formula mass for ionic compound may not correctly be referred to as a molecular mass. So we're going to calculate the same way. So I have sodium, I have a chlorine, so sodium chloride. So we're going to count the number of atoms and then multiply by the average atomic mass, add all together, and we have the formula mass. But you cannot call molecular mass. So the mole, we know the mole is a quantity. It's the amount of units similar to familiar units like a pair, dozen. And also you already know that 1 mole of any substance, any compound, anything, it contains, let me just grab my pen over here, that contains 6.022 times 10 to 23rd particles, atoms, molecules. This is Avogadro's number. Avogadro was a brilliant scientist that discovered that 1 mole of anything contains 6.022 times 10 to the 23rd particles. And in chemistry, we only work with the moles because moles is moles. 1 mole of water, 1 mole of carbon, 1 mole of oxygen. So we will always 1 mole. However, the mass change, as you can see here, 1 mole of carbon contains 12 grams, while 1 mole of magnesium contains 24.3 grams. So the mass always vary. So in chemistry, we're going to work with moles. And if you have a mass, you're going to use molar mass to convert. What is the molar mass? So molar mass is exactly the same thing in the formula mass. However, we're going to express the units in grams per mole. Is the quantity, is the gram, the mass in grams of 1 mole of the substance. So a single carbon atom has a mass of 12 atomic mass units. So a mole of carbon atoms have a mass of 12 grams. So we're going to calculate exactly the same way you learned before. And we're going to use the molar mass as conversion factor and also Avogadro's number as conversion factor. And this is very important for the next chapter where you're going to work with the stoichiometry. So we know the mass. So if you have the molar mass, you can find the moles. And if you have the moles and you know Avogadro's number, you can find the number of atoms. So let's practice. Here they ask what is the estimated average requirements of potassium in moles, and they are given to us in grams. So if you have a grams over here, we're gonna use molar mass to find moles. So the molar mass of potassium, you go to your periodic table and you're gonna see that 1 mole of potassium contains 39.910 grams of potassium. So we can cancel out grams and they're gonna have moles. In this case over here, so they give us moles and they ask grams, so it's opposite. So we again are gonna use the molar mass as conversion factor over here. But now grams up here because I wanna cut off moles and my unit is grams. So I multiply this and they're gonna have grams of argon. In this case here, they ask us how many copper atoms are in 5 grams of copper wire. So please pause your video and try by yourself before you see the answer. In this case, we have the mass. So if you use molar mass, you're going to find moles. And if you use Avogadro, I'm going to find the number of copper atoms. So simple. I can do directly, or I can do this step and then with the results I multiply by the atoms and then I'm going to find this. Okay, the way that you're going to do, it's up to you, is the way that you feel better to do. So you can do it step by step. Find the moles, and then with the moles you find atoms, and that's it. Let's go to next one. So I have a glycine over here. It's one of the amino acids that our body synthesizes protein from. So it has a molecular formula C2H5O2N. So how many moles of glycine molecules are contained in 28.35 grams of glycine? So I need the molar mass. So how are you going to calculate the molar mass? You're going to count the atoms and multiply the molar mass and add all together. So we have the molar mass and grams per mole. So now you grab the grams, and then you have grams over here down here, so you can cancel out the units, and you're gonna have mole of glycine. Just one more, so you can try by yourself, read the problem, and pause your video and try. This one is a problem that you need to think a little bit, because you have a molecule and they are asking exactly how many carbons atoms are in the same sample. So the first thing that you need to do is convert the mass that you have in moles, and then with the moles you can find the number of molecules. So I know that at each molecule I have 7 carbons, right? So now I have the molecules. So if you have 7 carbons in each molecule, the only thing that you need to do is multiply by 7. So, and then you're gonna have the atoms carbon, the quantity of carbon atoms. So it's simple, and if they ask you how many hydrogen atoms, you would multiply by 5. How many nitrogen will be the same? 1. So oxygen, I have 3, so 3 oxygen atoms, so we're gonna multiply by 3. Sulfur 1 will be exactly the same that we already calculated. Okay? So let's complete this table, and I really think that is a good idea to try by yourself. If you still remain some questions after watch the class, watch this review, and check the resource that I uploaded on Canvas for you, please don't hesitate. Just send me an email, ask me questions, and I will record short videos to explain to you. Okay, so don't keep your questions for yourself. Don't feel alone. So in this case here, again, please grab your periodic table. So I have magnesium. I have 1 mole of magnesium, so it's easy. So just check the molar mass of magnesium. So we're gonna find the mass and the molar mass. And here lithium I know is 6.9410 grams per mole. If I have a 13.88, I know that it's double of that, so I have 2 moles. So if it's 2 moles, I can multiply Avogadro by 2, and I'm gonna have the atoms. And the molar mass is over there, 6.94. Iodine, so I know that 1 mole of iodine I have 126.90 grams. So if I have 0.25, I will multiply 0.25, right? 0.25 moles, and then I have 1 mole of 126.9 grams of iodine. So cut over here, multiply this, and I'm gonna have 31.73. So I'm gonna do the same thing with the Avogadro. So I'm gonna multiply this by Avogadro, because I know that 1 mole is 6.022 times 10^23. So we're gonna divide this more or less by 4. So we're gonna have 1.506 times 10^24 atoms. So and now I have here the molar mass, right? And here, why I know that it's sodium, so I would not see the sodium before. I know that I have 2 moles because 1 mole is 6.022, so 2 mole will be this. This is not quite right. Let me just make the calculation over here for you. So it's 0. Okay, let me get my calculator. So it's 0.25 times 6.022 times 10 to 23rd. And then here is 23rd, not 24, sorry. I made a mistake here, okay? Of course, reduce, could not increase because it's 0.25. So here we did the same thing, so I know that 1 mole is 6.022 times 10 to the 23rd. So here, if I have a double, I know that it has 2 moles. So if I want to find the molar mass, I'm going to divide this by this, so it will be 45.98 grams per 2 moles. So we're going to divide this, and I will have 22.99 grams per mole. This is how I found out that it was sodium. So I went to the table and looked for 22.99. Okay? So let's test your understanding here. So I will ask you to do it by yourself. So if you cannot solve this, just send an email and I will help you out. Just to tell you, that's chromium. So we have a moles. So 5.5 moles of chromium, right? I know the molar mass of chromium because I have my periodic table with me. So I know that 1 mole is 52 grams of chromium. So we're going to cut this out, and they're going to have 286 grams of chromium. Okay? So next one, moles to grams and grams to mole. This is a huge problem because we need to calculate here the molar mass. So if you put it all together and you're gonna calculate this, you're gonna have 1,526.47 grams per mole. So, and I have 7.33.5 grams of cytosine. So, and I know that 1,526.47 grams and 1 mole. So I'm gonna find mole, which is 0.480 moles. So the challenge here was to calculate the molar mass. Okay. Again here, one more. How many ions of sodium are there in 25.2 grams of sodium phosphate? So ions. How are we going to do this? Ionosodium ions. So what is the first step over here? First is to find the moles, always. So molar mass. First we're going to find the molar mass. What is the molar mass of sodium phosphate? So if you multiply 3 times by the mass of sodium, which is 22.99, plus phosphorus, which is 1 times 30.97, and oxygen, which is 4 times 60, you're going to have 163.94 grams per mole. Now we can convert this to moles. So I know that 1 mole is 163.94 grams. So we're going to cut off over here. And we're going to have moles, which is 0.1537 moles. Okay? So I'm not rounding any number now because I didn't finish my calculations. So now I want to convert this to molecules, right? To sodium ions, actually. So I have, first I want to find the units. So I have 0.1537 moles, and I know that 1 mole is 6. Wait, you already know the answer. 6.022 times 10^23 molecule. So we're gonna cut off over here, and they're gonna have 9.26 times 10 to 22nd molecules or units. Okay, so molecule. So on 1 molecule, I have this. So if you wanna know the ions of sodium, remember what you do this, how you do molecule. So I know that 1 molecule, I have 3 ions, right? So we're gonna put here sodium, and then we're gonna find the number of atoms, which is 2.78 times 10^23 sodium ions. Okay, so that's it. So next one is empirical formula. Empirical formula, you know the percentage by mass of each element in a compound. So we have here 10-gram sample of a compound, which is determined to contain 2.5 grams of hydrogen and 7.5 grams of carbon. So to find the percentage, I'm gonna divide the part of the hydrogen divided by the total. So I have a 10-gram sample, and so I'm gonna divide the part by the total, and I have the percent composition. Okay, so it's always part by the total times 100. So that is the percent composition, mass percent composition. Okay, so the part divided by the total. So the percent composition, as I said, we always, if you want a percent element, so we're gonna find the mass of the element and divide by the mass of the compound times 100. Okay, so here we have another example. For compounds of known formula, the percent composition can also be derived from the formula mass and atomic mass of the constituent elements. So here we have a formula mass of the ammonia, which is 17.03. So what I need to find the percent of nitrogen and the percent of hydrogen is to know the atomic mass unit for those compound elements by itself. This is 14.01, right, atomic mass unit, and the hydrogen is 3 times 1.02, which will be 3.06 atomic mass units. So I'm going to divide the part by the total. So I'm going to divide the element that I want, so percent nitrogen. So I'm going to divide the part by the total. I have 82% is nitrogen, and only 17.76% is hydrogen. Okay? So the mass percent composition, this is the way that you're going to do. The percentage may not always total to 100% due to rounding, so it's depending how you round. So this is why I always round at the end. Okay, so when you have a percentage, you're gonna assume, if you want to find empirical formula, you're gonna assume you start with 100 grams of the compound. If it's in grams, you don't need to worry about, and you're gonna convert the grams to moles. Then you're gonna write the pseudo formula using moles, and then you're gonna divide by the smallest number of moles, and then you multiply all the mole ratio. So this part you already know how to do. We did this in the last class. So the goal here is to practice a little bit with you and check if you still have questions. So a compound here is determined to contain 1.71 grams of carbon and 0.287 grams of hydrogen. In this case, it's already in grams, so the only thing that you need to go is convert to moles. To convert to moles, I need a molar mass for each compound. Now that I already know the moles, I'm going to divide both by the smallest number of moles. So then I'm going to have, if I don't have whole numbers, I need to find whole numbers the exact way that I explained to you. In this case, we got close to whole numbers, so 1 and 2. So that is the empirical formula. So we have the mass of atom. So we divide by the molar mass to find the moles. If you have then when you have the moles of atoms, you divide by the lowest number of moles, and then you have the mole ratio, and then you can find the empirical formula. So a compound is composed by 53.73% iron and 46.27% sulfur. What is the empirical formula? Easy, right? So in this case, you're gonna assume that you have 100 grams. So I have 53.73 grams of iron, and I have 46.27 grams of sulfur. So you're gonna convert this to moles. After you convert this to moles, you're gonna divide both by the smallest number, and then you're gonna find the empirical formula, which is iron 2 sulfur 3. So if you still don't know how to do it, please rewatch the class, watch the empirical problem solving with drDias, and you're gonna find that. So we can find as well the molecular formula. So if you have the molar mass, you can divide by the empirical formula mass, and then you're gonna find the N, which is the ratio, and then with this ratio you're gonna multiply by the empirical formula all the atoms, and they're gonna find the molecular. So let's go over here. They are asking you to calculate the empirical formula. Again, we have the percentage. This is your time to review. So I'm gonna convert this to mass, and then I will find moles. So when you find moles, now I will choose the smallest one, which is this one over here, and you're going to divide both. So that is the pseudo formula. Divide both by the smallest. So in this is carbon dioxide. This is my empirical formula. So to find the molecular formula, as I said, you're going to find the ratio between molecular or molar mass of the molecular formula and divide by the empirical formula mass. So the molecular formula is then obtained by multiplying each subscript in the empirical formula by n. Let's do this. So here I have the empirical formula mass, 30 atomic mass units, and molecular mass of 180 atomic mass units. So you only need to divide, and you have 6, so you're going to multiply by 6, so I have 6H12 and O6. This is the molecular formula of this compound. One more, it's over here. So the molar mass of compound, 168 grams per mole, and its percent composition is 85.7% carbon and 14.3% hydrogen. Calculate the molecular formula of the compound. So I have the answer over here. I will ask you to pause the video and try by yourself. So in this case, first we find the empirical formula. So we're gonna assume 100 grams. So first you find moles after you assume 100 grams. So now we're gonna divide both by the smallest number, which is 7.14. So I have 1 and 2. So that empirical formula is CH2. But they ask the molecular formula. So the molecular formula, I need both molar mass, empirical and molecular. So I have the empirical formula, so I can calculate the formula mass, which is 14 grams per mole. And then I'm gonna compare the molecular molar mass, so divide, and I have 12. So multiply the empirical formula by 12, and I have C12 and H24. So that's it. That's all. Bye for now.